In this video, I'm going to show you a couple of things, and it's a very simple experiment, and you can get a lot out of it, a lot. But in principle, I'm going to show you this demonstration because it's quite neat. First things first, what you can see on experiment camera number 1 is a glass bowl. It's got a tea light in it. And can I just basically point out that you shouldn't be playing with fire at home, of course, unless you are a responsible adult. What I'm going to do is I'm going to set light to the candle, the tea light. And as I say, don't do this. If I can actually get, yeah, okay. And the chemicals I'm going to be using for this demonstration are, I've got a refreshing drink here, which is packed full of vitamins, seeing as it was an effervescent multivitamin tablet. The things that gave it its effervescence, which is worn off now, is I always put too much water in there, is citric acid and sodium bicarbonate, essentially baking powder, and citric acid. And they react together when they hit water, because both of them are actually solids. So citric acid is a solid acid, and it doesn't react with the sodium bicarbonate, which is slightly alkaline, and a neutralisation reaction happens there, and they don't react until they hit water, because then they get dissolved by the water, and then they can actually move along. And in the same way, you can make bath bombs from citric acid and sodium bicarbonate, and you mix them with, in order to make them stick together so they're not just powder, you mix them with a little bit of oil, and then you wrap them up in cling film, and then you leave them for a few hours, and they set rock hard. Okay, so what you can see here, there's the flame of the candle inside this glass bowl. Okay. It's not a very good candle, but there we are. It's been living on my shelf. What I've got here is I've got water, and I've got my citric acid, and I've got my bicarbonate, sodium bicarbonate, right? So what I will do is, and you can see I've got only the most scientific equipment here. So these are some baby spoons instead of a spatula, but there we are. And I'm going to use this to mix, well, actually I don't need to mix it, accurately weigh out a precise amount of baking powder. I'm going to add some citric acid now. Having added the sodium bicarbonate, I'm going to add the citric acid. Okay, and you can still see the candle is burning. What happens in that reaction between citric acid and sodium bicarbonate before the water's added is precisely nothing. And that's because they're both solids. The particles can't move towards each other in any meaningful way. Obviously, they can sit next to each other in the granules, but water is what they need to be dissolved in order to then actually exchange hydrogen ions from the citric acid to the sodium bicarbonate and then set off that reaction. So now, when I add the water into this, what will happen is you will see a fizzing, and hopefully some carbon dioxide being evolved. And since carbon dioxide is heavier than air, normal air is mainly nitrogen and oxygen, it should displace the air in this glass bowl. And by doing so, it will then starve the tea light of oxygen. Now, I've been talking for a while, and it's still going strong here, the candle. The candle will probably burn until it has no more wax. So I'm going to very carefully add water to this. And you can probably hear the fizzing. And there we are. The candle's gone out. Now, you might say, well, maybe the candle's just gone out. Anyway, I've got a match here. Whoop. I'm going to strike that match. Okay. And then I'm going to go in there. And so maybe that is a faulty match, right? So here we go. It's definitely burning, and there we are. Okay, So this reaction liberates carbon dioxide, and you can get a load of information from this. Firstly, as I said about the particles in the citric acid and the sodium bicarbonate not being able to move and react as a powder, it's still only fizzing where obviously the water went, and carbon dioxide building up. Can I show that that is indeed the case? Carbon dioxide is a colorless gas. Well, I've just lit a couple of matches, but if I agitate the air inside this container, so it's now displaced the air in this bowl to some degree. If I blow into it and I agitate the gas, I should be able to light a match and get it in there. Now it's still somewhat reacting. I should probably wait until it's. There we go. Okay, there you go. I've agitated the air, and I can now. Whoa, ow! I can now relight the candle. The angle is really odd. So it's still going somewhat, but obviously since I've blown in there, I've agitated the air, and the reaction has died down to a great degree, so it's not producing a lot of carbon dioxide. Anyway, I hope you found this demonstration interesting, and I might add a little bit to it when I get another chance of doing it again. Okay, see you in the next video. There we go. Okay, are you recording? Hello? Okay. So, which means I'm sort of borderline, but there we are. Okay, so this unfortunately is like a cake tin or something. It has a raised bottom. I'm just thinking. Anyway, okay, so thank you. Yes, 21st century technology. A match, right? It's it's delicious. Okay, but essentially the chemicals that are in there are obviously vitamins and minerals and so on. But I'm not going to bother giving you a recipe or whatever. You can look that up on the internet. Hey, you are on the internet. So there we are. Is maybe you can see that, right? Can you see? Okay, well, there we go. There we are. That's not enough. There you go. Okay, absolutely accurately weighed out of precisely known mass of grams. Didn't you get that? Oh, okay. And then I'm going to add some. Most of this will be cut, so there we are. Okay, and completely done. But that, oopsie daisy, dangerous matches. Don't do this at home, unless you're like responsible.